Hi everyone. Today we're doing chapter 10 of the book, which has its topic or section in maps, hash tables, and skipped list. So we're gonna do the exercise. We'll see which one we manage to do. But maybe we should start understanding what is maps and dictionaries. In Python we have a class called dict, which means dictionaries. It's actually the most significant data structure in the language. It represents an abstraction known as dictionary. Dict, it's a abbreviation or a shortcut of dictionary, in which unique keys are mapped. Maps are mapped to associate with values. Because of the relationship between keys and values, dictionaries are commonly known as associative arrays or maps. In this book, we use the term dictionary when specifically discussing the Python dict class, and the term map when discussing the more general notion of abstract data types. Maps and dict or dictionary can be interchangeable. Means you can use either. But once you see maps, means that's where we use this is a key and this is a value. So these are mapped together. This is a list in Python, and then a list. These are currencies. So the a list are keys, and then the values are currencies. So a dictionary there's the kind of way it associates a certain value to a certain key. So we can search. So you can search a value based on the keys. Let's say we're looking for a realer, we can search Turkey, which has a currency realer. Sometimes values are shared within the keys. Like Spain and Greece, they have a share of euro as a currency. We note the keys, the countries' names are assumed to be unique, but the values, the currency units are not necessarily unique. For example, we know that Spain and Greece both use the euro for currency. Maps use an array like syntax or indexing, such as currency of Greece, and this Greece is a kind of an index Greece. And then to access a value associated with a given key or currency, Greece is set to Tramcha to remap to a new value. Unlike the standard array indexes for a map need not to be consecutive or even numeric. Common application of map including the following: a university's information relies on the sum of form student ID as a key that is mapped to that student associated records, such as the student name, address, and course grades. Saving as a value. The domain name system maps a host name such as www.willy.com to an IP address, which is internet protocol, such as the 208.215.179.146. Social media site typically relies on an numeric user name as a key that can be efficiently mapped to a particular user associated information. A computer graphics system map name may map a color name such as turquoise to the tuple of numbers that describes the colors RGB, red, green, blue, representations such as 64, 224, 208. Python uses a dictionary to represent each namespace, mapping and identifying such as mapping and identifying strings such as pi to associated objects such as the value of pi, which is 3.14159. In this chapter, next we can demonstrate that a map may be implemented so that a search for a key and its associated value can be performed efficiently, thereby supporting the fast lookup in such application. The map ADT abstracts data type. It got the M of K, return the value V is associated with the key K in map M, M of K assigned to V, associated value V with the key K in map M, replacing the existing value if the map already containing the item. At del, M of K delete or remove the remove from map M. Remember, map M is just a list. The map is just a list associated array. M that item with a key equal to K. If M has no such item, then it raises an error, which is key error. The length of M, which is the length of M, return the number of item in the map. In Python, this is implemented with a special method test dash len, and then it's or iteratively default iteration for a map generating a sequence of keys in the map. We can also use K in M as such, kind of like a for loop. Return true if the map contains an item with a key K. In Python, this implemented with a special container method. Remember, these are built-in methods, like of contain, its, len, or we can say delete. These are already have that built-in within the Python language. M.get into K, D assigned to 9, return MK if M of K if key K exists in a map, otherwise return a default value D. This provides a form of query MK without the risk of a key error. Set defaults. If the key K exists in the map, simply return M of K. If key K does not exist, we set the value to D. And then we have M.pop of K, D assigned to none, remove the item associated with the key K from the map and return its associated value V if K is not the map. Pop item, remove the arbitrary key value pair from the map and return a key V, example representing of the remove here, dot key, remove all the key value pair from the map, d dot keys, return a set like view of all the keys of M dot values, return a set like view of all the values, M dot items, return a set like view of KAV tuples for all entries, M dot update into M, we're assigning M of K to V for every KV pair into the map to M2. So we have a new map or list, which is M2. M equivalent to M, we check the value if they are equally or at have identical key value. associations. We say if not this negation, we say if they are not equally, return true. These are typically operation. It's a len. We're checking the length of list M. It is 0, so the map is empty. We mk with a value k assigned to 2. This is a key with a value 2. And then we added another a new list, which is value key b with a value 4. Another list until we have such list. And then we have MP, we check if which value in the key B we have, which is 4. It's in the value 4. You can see here. And then x does not exist. We check on the list. A loop does not find x, so we return a key error. And then dot get view. So when I get a value, we check the key which is f in the list. We check it does not exist, so it says none because it has no value. And then dot get here we check and then also we assign with the value 5, so it gives 5. M dot k k5 is check if k, but also assign to k, but give the old value, which is 9. And then we check the length now. Remember first we check it was empty, it returns 0. And then now we check length M, the list now it says list 1, 2, 3, 4. So we give it the value 4. And then we delete V because we deleted if it is V, this V is gone now. We check delete and then we check dot pump K. Now we remove K9 is gone. And then we check the key value. We check the key. Remember the keys are first value, so these are keys like these are assigned as alphabets. These are keys. So when we check the keys, it must give us those alphabets. And then we check the values, must give us the number. Check the item, it gives us B, all of it, because item include key, it gives keys and value. And then we set the default, it checked it is B, and then it said the default, which is 4, that the value. It said the default of A, it does not exist here. So it's gonna set up the new value, give it 1. Dot IP to remove the whole set of key and values pair of B4. So we're left with these values. Operational, that's how that's how the maple dictionaries works. Okay, let me try and record this. I think I coded before, but for sake of our time, we can just do it. We have assign a list which is empty frequency, and then we go for a follow piece in open the file. We need there's a file that we're opening it, and then we read the file, checking the low case, we split the weights. The data student only consider the appropriate character with this piece, and then assign the weight. Weight is with an empty, and then it's joined for. We're using the operation loop for C in piece if C is alphabet, and then if weight, record the weight, then assign researching the weight, right? And then assign to 1 to add. So we're counting the weight that are in the weights. And then we're checking the maximum, which is empty for now, none. Count is at 0. We're checking with the key value W and C in frequent items. Remember, items search for both keys and value. If 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 the value is greater than the maximum, greater than 0, and then assign account to key, search for max, and then we assign count to C, which if it's greater, we check the greater one, the largest, and then we're printing the maximum weight, and then we print the number of currents of the maximum weights. I think I did. Okay, we have a frequency, which is a list or a map is empty. And then I created a file name, which is file.txt. Yeah, which, yeah, you see this file I created there, .txt. It has, I'm not sure you can see, it says a text file. It's gonna search which is the maximum weight here. So text, I think this file, and then also this file, and this is file. So it look like the most occurring weight is 5. This also is another 5. This is also another 5. This is also another 5. This is another 5. I'm not sure, I don't think this one is counted because it's counted as one weight end of the file. So it won't count file within set another weight file. So then it's called, it's reading, remember this file is reading the one there. Is everyone okay with that? Semi good. Okay, as you can see, the file is three. The most frequent weight is 5, and then its number of occurrences is 10. There are 10 number. The 10 file name in that document that we created. Hunter, I'm not sure what you mean. We should move to chapter 11. Chapter 11 for reading or to do exercises.
I'm not sure which one to want. Must you read and we do exercises? Then we submit to the
We push it
to our study group, GitHub.
Okay, I'm okay with that. If you wanted to read, and then we push.
I'm looking at the
Semi.
time because we still have more time.
Semi, which one you prefer? Yeah, let's go outside. Okay. Okay. Check chapter. But now it's already time is going to chapter. We're not going to finish the whole chapter. Chapter 11, such trees. And it's got seven section. That's so long. We're not going to finish this chapter reading here.
Okay, that's noted.
Is it hard to read alone? We can just change this strategy and then do reading, and then maybe whenever we got a charm, we do exercises. You can read as
Not
a
a
group,
problem.
and
I'm
then
fine with that.
exercises will do whenever we get a chance.
I'm okay with that.
But that's maybe later we can start it next shift. But now next week, because next week we're supposed to do chapter 11. Because this week was for chapter 10. Unless unless we can read chapter 11 next week, whatever time available, and then we can just do also exercises.
Okay,
I
not a
guess today you
problem.
can just do one.
We can do the exercise 10.6.
I guess you can just do exercises where possible or reread them. I did try to do some. Okay, let's go there. I give a concrete implementation of a pop method in the concept of the table mapping class, relying on the five primary method. Uh, so they say we must do, remember pop method is to remove item, either value, either certain key or value. So this is our important thing to check when you're doing the exercise in this question. And also we must check on the multiple mapping class, and then 5 tracks method. So in my attempt, I imported the collection from the multiple mapping, which is a built-in class. And then from there, created my multiple mapping as a method init, which is empty. And then the assessor gets item. Remember those built-in method. And then there's the set item, delete or remove item. Iteration, we iterate method, check the length of the list, and then created the pop method. Just try value if it's on the key, delete the value. Remember this, you need to delete the remove. So I'm calling this method is item, and then if it's none, if it's none, and then return error. So this should run. We have map which is A and with the value 1, which is, and then there's a key map B with the value 2. So if I run this, I created this map that had two lists, so the output should be 1. It showed 1, which is 1, and the default C. This is the default, and then but remember it removed this P2, and then only left C. My channel explanation, I'm not sure it is that with initialization of the contractor init, created an internal dictionary store to keep the item, creating this method to retrieve the value associated with the given key from the store dictionary. We set the method, the value for the given item in the store dictionary. Delete this item method, delete or remove the key value pair from the store dictionary, and then iterate, return the iterate over the key of the dictionary, and then checking the length number of the item in the key value. Pop method implementation attempt to get the value. We use self key, get the value associated with the key. And date, check the value, self key. And then return the value, retrieve value is then return, and then error. And an error, if the key does not exist, the error is caught or shown. If the default value is provided, it return the provided value. So it seems like the run is intended. We remove because they had two maps or two dictionaries, A and B, which are keys, and then these are value 1 and 2. We remove B, and then we're left with 1. Where's the another one? Give a concrete implementation of the item. Remember the implementation of the item means you search for key and value method in the context of the multiple class, rely only 5 threads method of the class. What will its running time will be if necessary applied to unsorted table. Okay, and then I call the multiple map from decoration.abc. I did this 5 item abstract methods which are built in create item, set item, delete, iterate, length. And then I created a method called set method that item return, which is return the key and the value. And two, which is map A, and then B, and then I'm printing the item. Two, support to print those method. And then the running time is linear. And then we have also a quadratic time. That's the running time method character by associated will be quadratic peak of n squared quadratic. It has printed a key value pair A1, B2. The same contracts are in it to do the same thing like the one that I did previously. Or the set, and delete or remove the pair, get item, and then we'll use the list comprehension, which is key for key in itself. And we run a for loop, which is the list comprehension set. It iterates, it goes around to all over the keys that's in the mapping, key value for each key, and then running some of the associated, which is quadratic. And then we run it. For give the concrete implementation of the item, a search for pet value, method directly within the associated table class, ensure that the entire relation runs in at a linear sum. I'm not sure this one today. I pulled the modular table mapping, and then created a class called associative class, which called the modular as a parameter. Created the init initialize constructor, which is an empty list, and then as a get the value. It's done for get the value and the key k and v. We assign the k to key, return the value. Then we return error if there is no item. It is the same thing. And then we use the list, and then we have it's supposed to output 2. And it does run on a linear. I'm not sure if I'm lying, but it seems so it's running in linear here. Comment. The provision ensure that the item runs in a linear time with respect to the number of key value pairs and associated value. Here we're using a list compression so that it's easy to, so it's gonna run on one, unlike when you had to run on a quadratic time. So it ran only one per list. So and then it become a linear item of a linear list. Okay, does push what was inserted to. We have less than less than 1 minute. Oh. So this is this, okay. Well, less than 1 minute. So this is what we did from exercise 1 to 3. Push on the GitHub so you can retry to do it. If there is anything that you don't understand, just ask me. Check the record those assignment and redo it. And then next week we'll try to do chapter 11. I think maybe you can do reading.